And dealing with n rectangles is actually going to be a little bit more difficult than dealing with an actual number like we did with the 4 and the 5 before. But I'm going to do my best to explain it. So let's first, again, draw out this curve x squared. So like this. So this here is going to be at an x value of 1. But now instead of having 4 rectangles or 5 rectangles, there's going to be n rectangles. So we don't know how many there's going to be. So what I'm going to do is I'm actually going to put a space in between. And what I'm just going to deal with is actually the ends. The 2 triangles at the end here, and then let's say the 2 triangles at the beginning. And because we don't know how many there are in between, we don't know what this n is going to be, I'm going to leave a space here, right? But the pattern at the beginning and the pattern at the end is going to be the same. So I'm going to work with those to try to create an expression. I'm going to start off by creating an expression for Rn, right? N rectangles. Now, what does the R represent again? Well, at each of these points, what it means is that each of these points is going to be the right upper corner of each rectangle. So if we draw these 2 rectangles here, like that, and then here, it's sort of, it's going to be this, it's going to be this rectangle, and then this rectangle like that. Right? So we're just dealing with the first 2 rectangles and then the last 2 rectangles, and in total in between this 0 and this 1 there's going to be n rectangles. So how can we create a general expression? So this is where it's going to be a little difficult. So first off, what is the length of each of these rectangles going to be? It's going to be the same. And because we're going from 0 to 1, and there's n rectangles in between, it's basically the distance from here to here is 1. So if there's n rectangles in between, it's basically going to be that distance, 1, divided by n. So each of these rectangles is going to have a length of 1 over n. Right? So if you remember when we dealt with 4 rectangles, each length was 1 over 4. When we dealt with 5 rectangles, each length was 1 over 5. So if we deal with n rectangles, each length is going to be 1 over n. So this 1 over n here that I wrote is actually the length of this first rectangle. That's what we're going to deal with, right? And what's this x value here going to be? Well, if we're starting at 0 and then this length is 1 over n, then we know that this x value is going to be 1 over n. Right? So the height of this rectangle is going to be f of 1 over n. I'm going to keep it general here. Right? So I'm not going to work with the x squared yet. I'm just going to write f of 1 over n, which represents the y value of this coordinate at an x value of 1 over n. And so what's going to happen is we're just going to keep going up by 1 over n. So this is 1 over n. Well, if we take 1 over n and we add 1 over n, what are we going to get? 2 over n. So that's going to represent the x value of this point here. Right? So this second rectangle, right, the area here is going to be the length, 1 over n, times f of 2 over n, like that, right? F of 2 over n is the y value at an x value of 2 over n, the y value of this point here. And that's pretty much the pattern. It's still going to stay 1 over n, the lengths of each of these rectangles, but the height is going to be first f of 1 over n, f of 2 over n, f of 3 over n, etc., etc., all the way till we get to this point, which is at an x value of 1 or at an x value of n over n. Okay, so basically we're going to keep adding the rectangles till we get to this last rectangle. I'm going to skip this second last one. I'm just going to put an expression for this last one until we get to 1 over n, the length of this rectangle, times the height of this rectangle, which is f of 1. But instead of writing f of 1, just to keep it consistent with all of this, I'm going to write it as f of n over n, right? Which is the same as just f of 1, right? So 1 over n, 2 over n, 3 over n, 4 over n, 5 over n, etc., all the way till we get to n over n, which is just that x value of 1. And so if you notice this here, these are the first two rectangles, and then we're skipping all of these, right? These are all going to be here until we get to this, right? So notice it's just a general pattern. The 1 over n's are staying consistent, 1 over n, 2 over n, etc., all the way till n over n, right? So that's the general expression there for the sum of all of these rectangles, where we're using the right upper corners of the rectangles. Okay, so what we can do now is f of 1 over n, we can actually use the function we're working with. In this case, we're working with x squared. So f of 1 over n is going to be 1 over n squared plus 1 over n, and then this is going to be 2 over n squared. Plus, keep going with the pattern all the way till you get to the last rectangle, which is going to be n over n squared. I'm not going to write 1 squared, I'm just going to write n over n squared just to keep it consistent, keep the pattern consistent over here. And then these dots here basically represent the area of the rectangles from the third rectangle all the way to the second last rectangle. And then this is the area of that last rectangle. And so from here, what I'm going to do is I'm going to distribute these exponents to the fraction, to the numerator and denominator. So this would be 1 squared over n squared plus 1 over n, and then this would be 4, let's not write 4, let's write 2 squared over n squared plus dot, skipping those rectangles to the, not skipping them, they're still inclusive, but not writing expressions for them, all the way to the last rectangle, which is going to be 1 over n, and then we'll have n squared over n squared, like that. And so from here, what we can do is notice that for all of these expressions, what's going to be common with them is the 1 over n and the n squared, which is like a 1 over n squared. Basically for all these, like this 2 squared over n squared, we could rewrite that as 1 over n squared times 2 squared. And over here, we could take out the 1 over n squared and just write n, the numerator. And like this bracket, we can rewrite as 1 over n squared like that. And so what I'm going to do is I'm going to factor out a 1 over n from all of these and a 1 over n squared like that. And so what am I going to be left with? I'm going to be left with just the expressions in the numerator. So we're going to have 1 squared plus 2 squared plus skip all the way to n squared.